Hey guys, how are you and welcome back to our new video. This is oxidation number part 3. In this video, I am going to explaining about remaining 4 tricks or methods to find oxidation number in easy way. I explained some trick in oxidation number part 2. If you didn't watch oxidation number part 2, first go and watch oxidation number part 2. Let's start our class. Now I am going to explain structure method and I am taking the example H2SO4. H2SO4 and I am finding oxidation number for sulfur. Now listen. We know that H2SO4 is applicable to some trick. Let's see H2SO4 is applicable to structure method or not. And now I am going to draw H2SO4 structure. Listen. And this is the structure of H2SO4. Listen now. Here plus 2, here minus 2. Here plus 2, here minus 2. Here plus 1, here minus 1. Here plus 1, sorry. Here plus 1, here minus 1. And draw a circle like this. And now we add this all. You get the answer plus 6. So finally we know that H2SO4 is also applicable to structured method. Why? The answer is plus 6 due to when we are doing in some trick H2SO4 we get the answer for sulfur plus 6. Now in structured method also we got the answer plus 6. Up to now clear? Note it. I think you all members have the doubt. Samir, here why you wrote plus 2, why you wrote minus 2, why you wrote plus 1 and why you wrote minus 1. Don't worry, I am there for you to teach chemistry in easy way. Listen now. First, I will explain why I wrote plus and why I wrote minus. Listen. Oxygen has high electronegative value. High electronegative value when compared to sulfur. When compared to sulfur. And sulfur has low electronegative value when compared to oxygen. Clear? If the electronegativity is high at that time, the symbol is minus. If the electronegativity is low at that time, the symbol is plus. Up to now clear? That's why here oxygen minus 2 and sulfur plus 2. Clear? Due to oxygen has high electronegativity and sulfur has low electronegativity. Clear? And now listen. Why I wrote here 2 and why I wrote here 1. In between this oxygen and sulfur, how many bonds are there? 2 bonds are there. That's why here 2. Here also 2. In between this oxygen and this sulfur, how many bonds are there? 1 bond. That's why plus 1 and minus 1. In this sulfur and this oxygen, how many bonds are there? 1 bond. That's why minus 1 plus 1. This sulfur and this oxygen, how many bonds are there? 2 bonds. That's why minus 2 plus 2. Up to now clear? Did you remember how here plus 2 came, how here minus 2 came? If the symbol is minus at that time, what is electronegative value? High. If the symbol plus, what is the electronegative value? Low. Remember. Okay. I think you all members have another doubt also. Listen now. Samir, why you didn't include this hydrogen and this hydrogen? Tell me. But you included these 4 oxygens. Why? Why? Listen now. These 4 oxygens are directly attached to the oxygen. Sorry, sulfur. They are directly attached to the sulfur. But this hydrogen and this hydrogen, they are not directly attached to the sulfur. If they are directly attached to the sulfur, at that time I will include. At that time I will include these 2 hydrogens. Clear? Here they are attached with the oxygens. Here they are attached with the Oxygens. If I am finding oxidation number for this oxygen, at that time I will include this hydrogen in this cell. But I don't include this oxygen, this oxygen, this oxygen, this hydrogen. Why? Because they are not directly attached to the oxygen. They are attached with the sulfur. That's why. Okay. If I am finding oxidation number for this oxygen, at that time I will include this sulfur and this hydrogen. I don't include this oxygen, this oxygen, this oxygen, this hydrogen. Why? Because they are not directly attached to the oxygen. Clear? I hope you all members understood H2SO4 in structure method. Now I am going to explain another example. H2H2O7. H2H2O7. In this, I am finding oxidation state for sulfur. And this is the structure of H2H2O7. Up to now clear? While doing these types of sums or these types of questions here, most of the members confuse and they do a very big mistake. They do a very big mistake. Before going to explain your very big mistake or before going to explain this sum, I want to tell you a small story to you. I want to tell you a small story to you all. Listen now. Actually, yesterday my best friend oxidation state called me. My best friend oxidation state called me and he told me that Samir, I want to tell you a very important point to you. I want to tell you a very important point to you. At that time, I told it, okay, my dear best friend, you can say me or you can tell me. And that important point is related to this question only. That important point is related to this question only. Listen now. He told me that Samir, I never find oxidation number to whole compound. Samir, I never find oxidation number to whole compound. I will always find oxidation number to only one atom. I will always find oxidation number to only one atom, even if there are two or three identical atoms. Even if there are two or three identical atoms, my answer is always for only one atom. My answer is always for only one atom. It means, listen now. Our best friend oxidation state is telling that he will never find oxidation number to whole compound. Whole compound. Whole compound. He will find oxidation number for only one atoms. Only one atom. In this compound, how many atoms are there? 11 atoms are there. 11 atoms are there. Among those 11 atoms, oxidation state is telling that I will find for only one atom. I will find for only one atom. What is that atom? We don't know. But in question, we know that we are finding oxidation number for sulfur. Oxidation number for sulfur. In H2, how many sulfur atoms are there? Two sulfur atoms are there. Two sulfur atoms are there. Listen, my dear student, a very important point. In this compound, we are finding oxidation number for H2 only. We are not finding oxidation number for H2 or O7. Actually, we are finding oxidation number for sulfur. We are not finding oxidation number for H2 or O7. H2 or O7. At that time, we don't want to calculate this O7 and this H2. We want to calculate just H2. In H2, we want to calculate for only one atom. Only one atom. Why? Because H2 have how many atoms? H2 has two sulfur atoms. H2 has two sulfur atoms. Among those two sulfur atoms, we want to find for one atom. What oxidation states tell us? Even if there are two or three identical atoms, I will always find for only one atom. What is mean by identical atoms? Same atoms. Here H2. Here two sulfur atoms means there are two sulfur atoms and they both are same and they both electronegativity also same. At that time we want to find for only one atom. At that time we want to find for only atom. Here this is one sulfur atom and this is one sulfur atom. Among these two, we want to find for only one sulfur atom. Only one sulfur atom. Either that sulfur atom is this or this. If we are finding sulfur atom for this, at that time we don't want to find for this. If we are finding oxidation number for this sulfur atom, at that time we don't want to find for this sulfur atom. Clear? 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 Any more doubts? If you have any more doubts, you can tell me in comment. I will definitely explain in oxidation number part 4. Okay? Now listen carefully. Listen now. In this structure, I am finding oxidation number for this sulfur, and I am not finding oxidation number for this sulfur. Why? Because even if there are 2 or 3 identical atoms, oxidation tell us I will find for only one atom. That's why we want to take only one atom. Only one atom. Identical atom means, remember, same atom. Okay? Listen now. If I am finding oxidation number for this sulfur atom, don't find for that. I am finding for this. +2, -2. If you are finding oxidation number for this sulfur atom, don't find for this. Okay? Here +2, here -2. Here +2, here -2. Here +1, here -1. Here +1, here -1. Draw a circle like this. When we add these all numbers, we get the answer +6. +6. So finally, we can say that H2H2O7 is applicable to structured method. Structured method. If you are finding for this also, you get the answer +6. Remember one thing, when we here what you will confuse means, listen now. Here you all members think that 2 sulfur atoms are there, and at that time we want to add oxidation number +6 and this +6. Don't add. When you add this +6 and this +6, you will get the answer +12. And you all members think that +12 is not oxidation for sulfur. And you also think that finally H2H2O7 is not applicable to structured method. H2H2O7 is applicable to structured method when we follow very important point. I hope you all members understand a small story. Okay? And note it. Note it. If you have any more doubts, you can tell me in comments. I will explain in easy way. Clear? Clear? Okay. I hope you all members understood H2H2O7 in structured method. Now I am going to explain two important points. Two important points. One is peroxy bond. Peroxy bond. Another is peroxy linkage. Peroxy linkage. Listen. What is mean by peroxy bond and what is mean by peroxy linkage? Peroxy bond and peroxy linkage are both are same, but there is a little difference. There is a little difference. Here peroxy bond means actual chemical bond, actual chemical bond between actual chemical bond between two oxygen atoms. Two oxygen atoms. Actual chemical bond between two oxygen atoms means wo. Okay. Peroxy linkage means structural connection of atoms through an OO group. Through an OO group. Structural connection of atoms. Structural connections of or connection of structural connection of atom through an through an VOVO group. VOVO group. Structural connection of atoms through an VOVO group is called peroxy linkage. Bond wo, bond wo. Clear? And listen one more point. Wherever you find peroxy bond or peroxy linkage, the oxidation state of that compound is always +6. Always +6. For example, H2S2O8. In this, I am finding oxidation number for sulfur. In H2S2O8, both peroxy bond and peroxy linkage are there. Then what is the oxidation of sulfur? +6 is the answer. Why? Because in the presence of peroxy bond and peroxy linkage, the answer is always +6. Now I am showing, wait a second. Up to now clear? Now I am going to rub it. And we also know that H2H2O8 is not applicable to some trick. Let's see H2H2O8 is applicable to structured method or not. Oh, wait a second. Now listen. H2H2O8. And this is the structure of H2H2O8. Here where is peroxy bond and where is peroxy linkage? This is peroxy bond. This is peroxy bond. And this is peroxy linkage. Peroxy linkage. What is mean by peroxy linkage? Structural connection of atoms through an VOVO group. Here these two atoms are connected with VOVO group. Clear? So what is the oxidation of sulfur here? +6. I hope you all understood structure method or structure trick in easy way. Now I am going to explain another trick, and the name of the trick is periodic table trick. This is our periodic table. Our periodic table trick is applicable to for only S and P block elements. It is not applicable to D and F block elements. Why it is not applicable to D and F block elements, I will explain in oxidation number part 4. Before going to start our class, once I want to tell where S and P block elements are located, where D and F block elements are located. Listen now. Here black line indicates F block elements. Here black line indicates F block elements. Clear? Now listen. Here red line indicates S block elements. Red line indicates S block elements. And blue line indicates P block elements. Blue line indicates P block elements. And purple color line indicates D block elements. And D block elements is also called as transition elements. Also called as transition elements. Clear? Okay, now I am going to explain where is first A group is located, where is second A group is located, where is third A group is located up to 8th A. Now I am going to explain. Listen now. Wait a second. This is first A group, this is second A group, and this is third A group, this is fourth A group, this is fifth A group, this is sixth A group, and this is seventh A group, and this is eighth A group.
Now I am going to explain where we want to keep plus and where we want to keep in minus in groups, and why we want to keep here plus and why here we want to keep minus. Okay, I hope you all understand where first A group is located, second A group is located, up to eighth A group. I hope you all understand where they are located. Now I am going to explain oxidation number of first A group. Up to eighth A group I am going to explain. Now listen. Oxidation number of first A group elements is plus 1 and oxidation number of second A group elements is plus 2. Oxidation number of third A group is plus 3. Oxidation number of fourth A group is plus 4. Up to now, I think you have doubt. What doubt means? Samir, why plus? Why first A group have plus 1? Why second A group have plus 2? Listen now. First I will explain why they are plus. Why? Because listen now. Up to fourth A groups elements have ability to lose the electrons. Ability to lose the electrons. That's why plus. And the oxidation number of first A group elements y plus 1 means they have ability to lose one electron, and second A group y plus 2 means they have ability to lose two electrons, and third A group y plus 3 means they have ability to lose electrons 3. They have ability to lose 3 electrons, and y fourth A group means they have ability to lose 4 electrons. Clear? And the oxidation number of fifth A group element is minus 3, and oxidation number of sixth A group element is minus 2, and oxidation number of seventh A group element is minus 1. Here also I think you have doubt. Why from fifth A onwards to seventh A, why they are minus, and why minus 3, minus 2, minus 1. Listen now. First I will explain why there is minus. Listen now. If a element have ability to gain electrons, at that time the symbol is minus. If a element have ability to lose the electrons, at that time the symbol is plus. Up to now clear? Now listen. Why there for fifth A group minus 3 means they have ability to gain 3 electrons, and y minus 2 means they have ability to gain 2 electrons. Y minus 1 means they have ability to gain 1 electron, and oxidation number of 8th A group element is 0. Why? Because they don't have ability to lose electrons and they don't have ability to gain electrons. Why? Because they are noble gases elements. Noble gases elements or inert gases elements. Clear? Clear? I hope you all understand periodic table trick.